Okay, it's recorded. Perfect. So I just wanted to come on the video and kind of introduce myself, and I'll get off the video just for the the quality of the voice and make sure that you can hear it properly. I will start off with talking about kind of doing data analytics in AWS and the value proposition of why you should be doing your data analytics in AWS versus on-premise. And then I will pass it on to Rio. So I'll take the first 5 minutes, and then we'll get into the meat of our seminar today. So let me turn off my video, and then I'll talk about analytics in AWS. Right. The main problem that most of our customers are facing is data volumes. Right. Data volumes are increasing at an unprecedented rate, exploding from terabytes to petabytes, and sometimes, especially customers, they're big, right? Exabytes of data. Traditional on-premise data analytics approach just can't handle those data volumes because they can't scale well enough, and sometimes are way too expensive to get more servers and more racks of servers in their data center, or may not even have enough space, right? So we hear from companies all the time, they're looking to extract more value from their data, but struggle to capture, store, and analyze all the data generated by today's modern and digital businesses. If you think about logging data, if you think about click streams, data is growing exponentially, and it's coming from new sources. It's increasingly diverse, and it needs to be secured and accessed and analyzed by any number of applications and people. So against this backdrop of the increasing data volumes and desire to get the right data to the right people, you have seen, right, with the COVID, 2020 has shown us that we need to be prepared and deal with this change. Customers are looking for highly scalable, right? To solve this problem, they're looking for highly scalable, available, secure, and a flexible data store, or a data lake that can handle extremely large data sets. With the data lake, customer can store all their structured and unstructured data using open data format of their choice. For example, Oracle or Apache Parquet, and tag their data in a central searchable catalog. But they need more than this, right? They need to be able to run multiple analytics services against their data in order to ensure they have the right tool for the job. They need to be able to move data between the data lake and services in all directions, from data lake to outside of the data lake, from outside of the data lake, for example, data warehouses, databases, coming into the data lake, right? They need to have a unified governance across data and services to simplify securing and managing and monitoring that access to the data. And of course, they need services that can give them a low cost without compromising performance or skill. So we call that the modern architecture for analytics, the modern data architecture. So let's dive into the meat of our presentation today. I'll pass it on to Rio. He is the co-founder for Ascending, and Ascending is our advanced AWS partner. It's very hard to become an advanced tier partner, and they've been there because they have done a lot of engagement with our customers, and they've created values for our customers. So today's workshop is going to feature Ascending and giving you this opportunity to learn about data lake. Rio?
Thank you, Sean. Hello, everyone. My name is Rio from Ascending. I'm a solution architect in Ascending, and my background is I have been doing first 10 years. I've been doing a lot of software engineer. From 2011, I started working on building application, data related application, web related application on the AWS from 2011. And the last 5 years, I was helping enterprise building data lake, data warehouse, anything related to data on AWS. Sean actually provided a pretty good overview of the data lake, the the challenge we have, and what is new, what kind of problem we need to solve, either on-prem or on the cloud. And a lot of enterprises try to think about a better way to make sense of the data. So in this session, we're gonna make an introduction to AWS Lake Formation. Before getting into the Lake Formation, first let's provide some background of big data trend. What's driving the revolution, and what is the current data trend? First, let's look at this picture. Usually, big data analytics project talk about having big data. You're gonna work with big data. Before we getting started project, everybody is very exciting. There might be assumption that it's going to be a very smooth transition. Just look like the guy standing over there. Unfortunately, it isn't easy. Given the diverse business and the technical requirement, you have a lot of different requirements. You have different team who will try to consume the data. You have different set of data, different type of data, structure, non-structure, semi-structure. You also need to store different type of format. Sorry, let me just turn off my video feed to improve our quality of the conference, the seminar. And we have different data structure, and people want to consume in different ways. Like Sean mentioned, you have different formats, Pocket, JSON, XML, different type of format. And suddenly, team find themselves in a situation like this, feeling overwhelmed by the data. So in the past, the decision making is around the data warehouse. We have a different type of application workload, line of business solution, online transaction process, ERP, CRM. We pull all the data into the data warehouse and have a BI application to provide you kind of a visualization of some of the data insights. We don't have first of all, we don't have the visibility of individual teams access. A lot of time, we just, some people going from one application to the other application, it's very hard. Secondly, it's very hard to process the different structure of data. There's a lot of overhead for a team to provide a granular access control. And also the visualization is not robust enough to provide a quick of data insight, make a critical business decision. And as Sean also mentioned, that the data scales so fast. The velocity of the data growing very, very fast. We want to building something that a data platform that could last 15 years. However, the data grows 10 times every 5 years. So you're talking about scaling 1,000 times in the next 15 years. So that it's very difficult to handle. And thanks to the IoT microservice architecture, different kind of the log data, different type of raw data, right? You have so many different different way to pull in different format of data. And the workload are totally different. There are more and more use cases in different industry. Think about it. We have done different use case. Just giving you a quick example. Let's say a logistic company. They have shipment information. They have foot traffic, and they have their own trading data. They want to find the best route for those shipments, so they can improve their profit. In a pharmaceutical company, they want to study a patient information. And in a financial institution, they have different type of information to study the fraudulent, to make the fraud, to improve the fraudulent detection. So there's a lot of different type of process, like real-time process, machine learning. You have to run larger size of query. Those are the real-time streaming, logs, IoT device. Those are the use case that we have to consider moving forward or right now that we don't have to consider in the past. We're increasingly see more and more customers giving government access to the data, democratize the data access, make the data available in a self-service manner with the security and the compliance boundaries. So you don't, you wanted to not only control control the access data access, but also you should be able to, audit and make it easy for people to access your data, at least your team member to access your data. There are multiple teams who want to access the data in a collaborative manner in an enterprise. For a use case ranging from business reporting to ad hoc analytics. They want the flexibility to self-onboard and share the data and make data available for analytics in real time, to be able to search, analyze data in a massive scale, and do so in a manner that adhere to the security and compliance requirement. So, just in our opinion, to summarize the big data challenge in most enterprises, there are three main pieces. First is ingest. Second is store. And third is analyze. Let's talk about the ingest. We need to be able to process different type of data. Maybe it's raw data. Maybe it's unstructured raw data. Maybe it's a JSON data. Maybe from the API. Perhaps it's from the IoT, Kinesis agent. Different type of data has a different ingestion method, right? And storage data has in the past, the data does not connect. Silo data prevent a single source of truth. You have a data stored in the Microsoft SQL Server, and you have somewhere else have a snapshot or have a copy, and you don't have the single source of truth of all of the data stored in different places. Analysis, limited analytics platform. You're not able to generate a new insight and generate new insights from existing storage. So those are the challenge in most of enterprise. And also you have a regulation. In some of the use case that we did before, you need a HIPAA compliance. You wanted to kind of absorb all of the data, but obfuscate the data across the different team. You have different obfuscation rules across different teams with same set of data. You have SOX compliance. You need to encrypt the data for certain financial information, and you want to decrypt. You want to be able to decrypt while processing when you do analytics. So different company, different organization have their own regulation rules. Before we get into the detail, I'm going to do a live poll. So in this poll, we just want to understand what is your current enterprise big data challenge, right? We have talked about the data ingestion. We have talked about the storage, and we have data analytics. I would like to understand what's your biggest challenge in your current organization. Okay. Shall we? Okay. Let's look at the poll result. All right. Seems like nobody has any challenge in the data storage. That's good. Um, half of the people, half of the attendees has challenge on the data ingestion, and third of 75% of people have a problem with to provide a more insight into into the data analytics, machine learning, and AI. So let's move on. We certainly gonna take those information in mind. All right, what is a data lake? So since we have talked about the the revolution, the data trend, what is the data lake? How do we solve those kind of new challenges and move forward? So a data lake is a centralized repository that allows you to store all the information. A data lake is an architectural approach that helps you to manage multiple data sets from a wide variety of the source, both structure, semi-structure, and unstructured. Structure is more like relational database. From my best knowledge, and the structure is like the database, relational database. You have company, payroll, people. Those are structured. Semi-structure is JSON, those kind of semi-structure. Unstructured is more like raw data, logs, IoT logs, those kind of unstructured data. So through a unified set of tools, you want to be able to manage those kind of data, different type of data in a unified set of tools. So it's readily available to be categorized, processed, analyzed, and consumed by a diverse group within organization. You might have a data engineer, you might have data analyst, you might have an application team, they want to consume that, but they have different requirements, how they decide to consume that. Since the data can be stored as it is, there's no need to convert to a predefined schema. You don't have to worry about how to store that. Just put it in, store stuff in. And whenever you need to process that, you can write an ETL process to process that. That's more like a on-demand, ETL process. You no longer has to design pre-design the ETL process based on the data format. You don't have to ask the data beforehand. So the data lake allow you to break down data silos and bring data into a single central repository. As we mentioned, we can store a wide of a different data format at any scale, at low cost. Data lake provides you a single source of truth. So you store all the data there. Whenever you need to find the data, go to the data lake. You don't want to ask for the application team A. In our organization, I don't have to go to a Celeste, hey, give me some of the data of a certain financial record. All I need to do is go to the data lake and find the right tables, and access the data. And allow you to access the same data using a variety of analytics and machine learning tools. I'm sure 75% people is interested in that part. We're gonna talk about more. So so data lake is a little different from traditional warehouse. All the data are going to a landing zone. So all the data are going to the landing zone here. You have different device IoT, you have a web transaction, you have a sensor information, you have social media, everything going to a landing zone. It can scale out petabytes, exabytes, query in the S3 and the cluster. If your data, if you store data into the data lake, you can write a larger query to query a larger set of data from existing storage. It's Apache ecosystem friendly for analytics. You can interact with the data real time. and you can, you can provide a visualizations, and you can use a SageMaker and machine learning. All right. Next one. We're gonna do another poll before we get before we take a break. More information before getting into it deeper. Are you planning to implement data lake for your organization? Are you currently implementing a data lake for your organization? Are you planning means you're kind of using on premises, or you're using the data warehouse, you decide to move to the data lake, or you're currently trying to implement a data lake, or you're in the process of implementing data lake. Have you already completed data lake implementation, either partially or fully? Means you have a functioning data lake, and you're adding a new feature into your data lake, or adding more data into data lake. Okay, so well, it's 1/3, 1/3, 1/3. All right. Okay, let's move on. Thank you. The next session, the next part, we're going to talk about the concept of the data lake. So we want to store all the data in one place, a single source of truth. We wanted to handle structured, semi-structured, unstructured data, right? And we want to make the ingestion much more faster, even real time. So I'm not gonna go through read through the entire things, but there's a couple of things you want to consider. You can store all the data as it is without having to first structure the data and run different type of analytics, from dashboard to and visualization to big data process, real-time analytics, and machine learning. That way the data lake allow you to decouple the storage and the computing. We store either raw data or process data in the S3 without running the servers. We can rapidly ingest and transform data on the AWS through Kinesis, Firehose, Kinesis, and transform the data in the real time in about 1 or 2 minutes. We can secure multi-tenancy. We can run the query through Athena query. We're actually going to talk about the Athena query later in the lab session. Schema read. We will demonstrate how Glue catalog the data. So those are the things we're gonna talk. There are a few things we're gonna talk about later in the lab session. It turns out there are only there are quite a few steps involved in building the data lake, but I'm going to try to break it down into only 4 or 5 pieces. Structurally, just into 5 pieces, so it's easy for you to remember or understand. The first piece is set up a storage, a landing zone. As we mentioned, we want to put everything into one place. We don't have to pre-design any of the ETL for our data, but instead we want to put all of the things into same place as a landing zone. A data lake holds a massive amount of data. Before doing anything else, customer just need to set up a storage, hold all the data. If we're using AWS, then we can configure S3 bucket and the partitions. If we're doing this on-prem, then we need to acquire hardware and set up a larger disk array to hold all the data for their data lake. Secondly is moving the data. Customer need to connect different data source on-prem, in the cloud, or on IoT device. They need to collect and organize relevant data sets from those sources and crawl the data to extract the schema and add the metadata tags to the catalog. Customer do this today with a collection of transfer and ETL tools. So the moving data, like if you're doing this on the AWS, you're probably going to use AWS Glue to move the data around. The third piece is clean catalog data. So same thing, you have to partition the data, index the data, transform some of the data into the columnar format to optimize performance. You need to somehow clean the data, remove the duplications, match related record. A lot of time in an organization that we're currently working with, a lot of time this was done through the SQL. It's really not that, I wouldn't say SQL is bad, but sometimes it's very slow. You really need to think about the right tools in the right scenarios. So the transforming incoming data is complex. You sometimes have to monitor that as well. The first one is configure enforce the policy. Sensitive data has to be secure according to the compliance requirement. This means creating apply data access protection compliance policy to make sure you are meeting the required standard. For example, restricting access to personal identifiable information at the tables, right? Column, row level, encrypt all of the data. Right. Sometimes you just need to, restrict certain people to access certain tables or only certain column. I don't want I don't want a team A to be able to access my SSN information, the SSN information column, in real life example. Today, customer using access control list on the S3 bucket, or using a third party to encrypt and access control software to secure the data. So you have a different kind of vendor to do that. And for every analytics service that need to access data, customer needs to create and maintain data access, protection, and compliance policy for each one. You have different analytics you need to access, then I have to maintain policy for that. The last one is to make it easy to find the data. So it's more like a discovery, self-service discovery. Different people in your organization, like analytics, data scientist, like analyst, data analyst, and the data scientist, they may have trouble finding and trusting data set in the data lake. So you need to make it easy for those end user to easily find the relevant and trusted data, single source of truth. To do this, you must clearly label the data in a catalog of data lake, provide the user a guidance, ability to access and analyze the data without making requests to IT. What we did, I'm just gonna make a very simple example. What we did for one of the client, logistic company, they have a huge set of different data. So what we did is we built a very simple HTML page, right? And then pull the catalog through the Glue catalog through our data lake catalog API through AWS SDK, and kind of list out what are the data and give a remark for those each data set. That way, whenever a vendor or any of the IT personnel logging to the single sign-on, they look at the page, they know what type of what set of data are available to them, and they can, either make a request to the data relevant data set, or go through the self-service manner in the data lake to get the data access. Each of these steps involve a lot of work, because today a lot of those are done manually. Customer can spend a month. You can spend a month to building a data access and transformation workflow, mapping security and the policy setting and the configure tools, service for data movement, storage, cataloging, security, analytics, and machine learning. With all these steps, fully production ready data lake can take a month to implement. That's the point I'm trying to make. It looks easy. I break down into 5 pieces. However, each pieces take a lot of time to build a reliable, productionized system to support it. Next one. So there are a lot of analytics work, but the most important things. So as we mentioned, everything starts from the landing zone. The most important thing, to be honest, is Amazon S3. The reason is that you can put a different type of data into S3, and you can connect the different type of service, machine learning service, analytics service, on-prem. Some of the on-prem application, you can also pull in ingest the data real time into S3. And S3 is secure and highly scalable and durable with millisecond latency for data access. You can store any type of a data format. You can even set up a lifecycle integration, such as moving from a standard storage in the S3 to infrequent access to a Glacier, based on the sometimes based on the age of the storage. You can even set up replication policy in different region for DR. And S3 are natively supported by Spark Hive. You can decouple the computing. You can run in EMR and Spot instance. You don't have to pay data replication in the same region. You can encrypt the data at rest with very low cost. With the cloud, it has never been easier and most cost effective to collect and store and share, analyze the data. So, okay, so this is the last slide for this section. Yeah, so you will see more and more company, more brand are building a data lake on the AWS and building the analytics on the AWS. Okay, before we get into the next session, I'm probably gonna take a few minutes break and do a Q&A session. Gloria, do you want to announce something?
Yeah, sure. First of all, thank you for coming to the event. Just want to mention that if you stay along for the entire event, you will get a gift card. And if you get, we'll provide this QA session along this event. And if you get a high score, you will get $100 on a gift card. So yeah, do vote to join. Okay, so can we pull out the first question we have here? I think we have, there's two questions. So I think we have about 30 seconds or 1 minute to answer these questions. Once you're done, you can just submit the answer and we'll see if the, I don't know, please join this session if you we have hit the time or the majority of people already pick the answers. We'll go ahead and show the result. This question is not difficult, right? I mean, I can answer it. At the same time, if you are already done with submitting these questions, take a break, get some coffee, and if you have any questions to ask our panelists, you can ask questions in the QA session. The QA session is located at the bottom of this window. You will see Q&A, and you can go there, type your question. Our panelists will see the questions, and if they may get the only answers during the presentation, they will mention it. Okay, I think that's all. Can we see the answers, Harry? Okay. We have, yes, Riel, do you want to explain this answers or anything? So most of the you guys is answered correctly. This is S3, the storage. Okay, sorry, go ahead, Riel.
Yeah, thank you. Mainly used as the data storage in the data lake is S3. Which of the following data belong to the structured data? PostgreSQL, data tables in PostgreSQL. It's a relation database. That's why we call it structured data. JSON data is more like, semi-structured. You can say it's structured, but it's more like a semi-structure. Which of the following components are part of the data lake infrastructure? Storage, ETL, and analytics. Database weekly snapshot. We don't usually count that as a component of data lake infrastructure.
Okay, let's continue. Harry, can you close the question and we can proceed?
Let me reshare. Something wrong with my PowerPoint. Okay, let me share again. Okay. All right, moving around. So we have talked about the big data trends. What's driving the revolution? What's the most challenge? What are the challenges in the enterprise recently? And what is a data lake? It's an architectural approach, right? It's not really a specific service, but we wanted to build a platform that can last for 15 years to hold all of the data that you need and to be able to analyze the data and provide you insight and make the best decision on your business. Then why did we build AWS Lake Formation? So the answer from AWS team is to build a lake formation. Is using Lake Formation to build a data lake. Why do we use that? So let me get into it. So before we get into this part, I just want to take probably 1 or 2 minutes to talk about our company overview. Talk about us. Ascending is a cloud enabler, provide a cloud strategic consulting and cloud migration and cloud operation native applications development service. We are a minority-owned business. Those are the certification we have. In addition to it, we also, as Sean mentioned earlier, we are advanced consulting partner. We're Microsoft partner. We're Snowflake and a HubSpot partner as well. For main service, if you're interested, I'm not gonna expand too much to expand here, but if you're interested, you can go to our website. For main service is DevOps, application development on the cloud, native development service, serverless development, and containerization development on the AWS, big data, data governance, analytics, reporting, and infrastructure management. And the last one is cloud optimization. Okay, so that's the quick introduction of Ascending. Then we're getting to the the main piece. Sorry, we're getting to the main piece. So we wanted to build a clean, secure data lake, but it could take a month, right? As we mentioned, it could take a month. How do we do it? How do we do it faster? How do we cope our current technology innovation trend? How to make things faster? How to get the business value as quick as possible? There's a recent study by Crowdflower who surveyed 80 data scientists about their job. they found that data scientists spending 60% of their time on cleaning and organizing data. Collecting data sets come at second, 19% of their time, which means 80% of their time is preparing and managing data for analysis. They're not doing any of the data modeling, right? They're not doing what they're, the best. They're not spending, they're only spending 20% of their time doing what they do best. We don't want that. They also found that data preparation was the least enjoyable part of their work. Data scientists, they don't like to write a script and then make a robust ETL job. What they really want to do is, and that's what they're good at, is building a model to extract all the data, building the models, fit into the models, make sense of the data. The question we have is ask ourselves, if we can make the data preparation easier, can we minimize the time that people are collecting data set and cleaning and organizing their data? So we want them to do refining algorithm. Right. So there are a couple sample steps required. First, you need to have a database instance, set up a database instance. Second, you have to create a storage. I'm just talking about AWS since it's already the easiest they provide the best tool on the market and the easiest way for you to try to store data and make sense of data. But still, there are a lot of steps: creating storage on the S3 location, configuring access policy to secure your data, and mapping tables to the S3 location. Build an ETL job, write scripts to load and clean the data, create the metadata access policies to control IAM policies to control who can access the data, and then configure access for analytics service, and repeat for other data sets and more. Manage and monitor ETL jobs, update the meta data catalog as a data changes, update the policy across the service as user and permission change, manually maintain cleansing script, create an audit process for compliance. There are so many steps. I couldn't even remember the first image we just show you, but there are so many steps to do it. It's manual, it's error prone, and it's it's time consuming. All right, so what Lake Formation provides us? Gladly, that the AWS has a managed service called AWS Lake Formation. What Lake Formation provides us is a fully managed service that enables data engineer, data stewards, data analyst to build and clean secure data lake in days. So we literally actually this is one of our experience with the client. We literally built a production-ready data lake in 2 weeks. The first week, we built something that is working. And the second week, we're testing out. We pull some of the data, pull some of the data source into the data lake and start serving different people, different team. So it's really quick for you to build a data lake using Lake Formation. And as you feel about as you experience probably with other managed service, it's like ECS or a roller. It's very stable, right? And it reduces overhead of your operation support. So the Lake Formation solution stack. Oh, sorry, too fast. First, AWS S3 as a data lake storage, cost-effective, durable storage with global replication capability. Means you don't have you have a container. I wouldn't call it a container because this word is very sensitive. But you can consider as a container that can store all different type of data in for your organization. as S3 is very reliable. Second part is a simplify ingest and cleaning enable data engineer to build it faster. The third one is centralized management of fine-grained permission, empower security officer. So you can, there's a manager's service that you can provide a person or a team with a particular access to one table or one column. And the centralized management, discovery and sharing integrated tools to enable every users. So you can integrate with a lot of AWS tools, Athena, QuickSight, Redshift, Glue, SageMaker, EMR, and so, a lot of tools. All right, so sorry, I flipped too fast. The next one, we're gonna do a live poll again. Since I have talked so much, can you? There are a lot of components in the Lake Formation. Can you tell us which components in the Lake Formation are you interested in most? Data discovery, access control, ingestion, and cleansing of the data. Okay, looks like we have 1/4 of people interested in access control, and 75% of people are interested in ingestion and cleansing of the data. Then very good. So we have 2 labs. After this session, we have 2 labs. One is talking about Lake Formation. I'm actually gonna go through that, but just give you a high-level understanding what's coming. The first lab session is talk about a blueprint. So essentially, it allows you to process, run the ETL on the data, in a very quick way. A second part is access control on the Lake Formation. So this picture, the idea is that in the big data, there's no silver bullet solution library to solve all the big data. As you have different superheroes, each with his or her own strengths, you will be needing different tools in big data. So you need to get the right tools for different data structure. Think about the data structure. Think about the latency. Think about the throughput. Think about your access pattern. Find the right hero for you. Well, I like Iron Man because he is kind of rich. Okay, so we talk about the next session. We're gonna talk about the blueprint. So the AWS Lake Formation is built on top of AWS Glue capabilities. So in the next sessions, Leslie's gonna talk about blueprints, workflow. How does she set up a blueprints and workflow with examples? Before we get into that, I just want to give you a quick overview of what is AWS Glue, just in case you're not familiar with that. So AWS Glue so provides a scalable serverless component. We have 4 different components. I will start with crawler, the second one. The AWS Glue crawler can scan data in all kinds of repository, relational database, the PostgreSQL, MySQL, classify it, extract schema information from it, and store metadata automatically into the AWS Glue catalog, the catalog. The Glue catalog can then use to guide ETL. And what is the catalog? The catalog is a persistent metadata store. It is a managed service that able to store, annotate, and share metadata in the AWS cloud in the same way as Apache Hive Metastore. It's also integrated with other analytics service for example, user can use Athena to query files in the S3 bucket based on schema in the Glue catalog. That's why Glue catalog is the most important piece. But with crawler, but the first thing is you have to run the crawler so you can get the data catalog. Then the serverless ETL, using the metadata in the data catalog, Glue can automatically generate a Scala PySpark script to perform various ETL operations. For example, you can extract, clean, and transform raw data, then store the result in a different repository where it can be queried and analyzed. So that's the third piece. The last piece is the flexible workflow. The AWS Glue Jobs system provides a manager infrastructure to orchestrate the ETL flow. You can create jobs in the AWS Glue and automate the script to extract, transform, and transfer data to a different location. Jobs can be scheduled, chained, and they can be triggered by events such as arrival of new data. So you can orchestrate a different workflow. You don't have to worry about the underlying infrastructure, just run it. So that's the power of AWS, right? It's a managed service. You don't have to worry about the underlying EC2 or hardware. Are they capable of doing it? You just need to run it. You don't have to worry about the operation overhead. And then it provides a robust integration with different triggers. In the past, Celeste can talk more later. But what I remember is we did different things for various clients. You can trigger by S3 event. So you drop a file to the S3, trigger the Glue job crawler. We even have a YouTuber talking about that. You can also trigger by the CloudWatch event. There are multiple ways to trigger that. And you can also integrate with alerting, right? Just in case some of the workflow failed, and then some of the workflow failure, then you can get in and look at the log and try to fix that. Some of the success story, we built a secure data lake for a customer in the logistics industry to be able to scale up the ongoing data acquisition process. They have multiple data sources they like to acquire within a very limited time frame, which is several downstream applications to provide a market insight for making critical business decisions, such as data analytics, reporting, and machine learning, and more. In this project, we use the AWS Glue to connect to internal data source, like RDS, S3, DynamoDB. We built some application using DynamoDB, and RDS is their existing, the existing older applications data repository, and S3. An external data source like third-party API, we ingest that through Kinesis. We manage the data lake using a lake formation and share different permission with the analyst, BI developer, data scientist, so that they can use Athena to run the ad hoc query, use a QuickSight to generate a dashboard and insight, and use SageMaker to run. We even partner with the AWS Blue Badge team because they are responsible for the SageMaker to run machine learning models. So we just we actually partner with them, grant access, make access control, build the ETL according to their needs. All right. So the next part is how does the AWS Lake Formation help you? So it's going to be a lab session. I will toss the microphone to Celeste. She is gonna introduce you how to using AWS Lake Formation blueprints to automate the workflow. Celeste.
Yep. Thank you, Will.
I'm going to stop share, let you share by yourself.
Sure. Okay, let me share my screen. There's something wrong. Okay. You can see my screen, right?
Yep, clear.
Okay. Okay. Hi. Good afternoon, everyone. Thank you for coming our immersion day. My name is Celeste, the data engineer in Sydney. I got AWS certifications in big data specialty and a solution architect. I've been working on several projects using Glue and Lake Formation to do ETL jobs and help our clients on their data ingestions and migrations projects. So Real in the previous sections, he has introduced what is Data Lake and why we use Data Lake, and give you some idea about what is Glue. So now I'll focus on how to actually build a Data Lake, how to ingest the data into Data Lake, especially ingest data from common data sources such as S3 and RDS. So let's get started. So I personally consider Data Lake is like a tote bag that centralize all your items, and think about people, why people buy tote bag, because they may need to carry big items, or they have a lot of items to carry on. And a bigger bag should have enough space to put all the things together. So there similarly, organizations also have this kind of requirements to store relational data, non-relational, structured, semi-structured, and unstructured data at a very, very large scale. So let me give you a real-world example here. Toyota developed a connected data lake architecture to store the raw data, decoded data, and enriched data in the same data lake. Raw data are generally in semi-structured data formats like JSON, and they are often non-relational. And data engineer, they could use the decoded data to do further ETL process and data preparation for data scientists and data analysts to do some ad hoc queries for simple operational purpose. And enrich the data after ETL are in well-structured and in a relational format that is easy for data scientists to do data mining and machine learnings to optimize the production process or dig out data insight for future business strategies. So with this data lake architecture, all the data are well connected and centralized, and all the users could conveniently use the data in this one single data lake for their same big and general business purpose. And so S3 and a relational database, as we all know, that they're two very commonly used data sources. And so how do we ingest the data from those two places into our data lake becomes a very hot issue for many organizations in every industry. So that's why in today's talk, we mainly focus on them. It is pretty common in different business that people have data in these two places, S3 and database. Like in a setting, we have some clients in e-commerce industry. They may put their transactional data into S3 and using relational database to store product data, logistic data, or other operational data. It is very common. So let's start from a simple one, from S3. So for data already in S3, it is pretty simple. We just register the S3 target as the data lake location. Then we're done. So let me show you how to do it in AWS Lake Formation console. Okay. So so first, let's go to the Lake Formation console and go to the Lake Formation and go to data lake locations, and at the upper right corner, we click register location. So here we gave a S3 location path that our data are located. And we keep all other things in default and click register location. So now all data in this S3 path has been part of our data lake. It's very simple, right? Okay. Ooh. Okay. So basically, 2 steps could register S3 location as part of our data lake. And by the way, it is also feasible to do the similar thing for S3 location that is not in your account, but that part of content is out of today's scopes. So I recommend you to check this video, to check this video here we made about how to do cross-account management with the Lake Formation. And you're welcome to subscribe our YouTube channel. Well, for data in S3, everything is pretty straightforward, pretty simple. It's just as easy as you're snapping your finger. But for data in database, the thing will be a little bit complex, and we need to think more and potentially do more things. But before we move on to importing data from database, let's do a simple quiz together. Ooh. Okay. Seems like most of the answers are C, D, E are the last 3. So S3 itself is just a storage services. It's not a data lake, but it is a storage layer of data lake. And for C, yes, I said we can register S3 location even not in our account. Lake Formation. No, Lake Formation is not data lake conceptually. It is a service to build and manage data lake. Okay, let's move on. Okay, let's continue our discussion about importing database data. As I said before, quiz for database data, we'll have more steps to work on. In general, we need to build a connection to the target database to access the data. And even if you got the data, usually you find it may be still challenging to use it immediately because the data probably not perfectly fit your needs. You may need to filter out some data, reformat it, mapping it, and so on and so forth. And those steps so-called transformation. Then after this time-consuming transformation process, we could pull that data into our own data lake. And this whole process is called ETL and could be handled by AWS Glue. And Glue usually works very closely with other services in AWS, such as Athena, RDS, S3, Kinesis, and Lake Formation we talked today. So if you want to learn more things about Glue, welcome to check this video in which we explain many basic knowledges and features about this service. So as you can imagine, building an ETL pipeline using Glue is not that easy, especially for a person without ETL experience. And even for the ETL professionals, it could take months to complete an ETL procedure, depends on how complex the pipeline is. As Rail might also mention in his previous section, Glue as a ETL service, it has many features like Glue connection, crawlers, data catalog, Glue jobs, etc., etc. So the learning curve for this ETL tool could be steep and uncomfortable for a team, especially who wants to build a data lake quickly. So is there any simple way to import the database data? And that's when Lake Formation Blueprints comes into our mind. The blueprints that bundled up all the required Glue features we mentioned above. You only need to provide very minimal inputs, then it will handle all the rest. Officially, a blueprint is a data management template that will generate a Glue workflow for you to ingest data into Data Lake easily. At a high level, Lake Formation provides two types of blueprints, database blueprints and log file blueprints. We will focus on the first one because it is used more frequently in many business scenarios. I'm going to give you a demo about this type of blueprint. But before demo, let's do another simple quiz about Lake Formation and Glue. Okay, so the correct answer is C. So they are different services, but they are related when we're building a data lake using Lake Formation. As me and Ariel also mentioned, Lake Formation is leverage the many features from Glue. So we cannot say they're irrelevant. Okay, let's move on to our demo. So the demo is about to import RDS tables into Data Lake using Lake Formation Blueprint. We need to prepare the Glue connection, Glue database, and IAM role before creating Blueprint. Glue connection is to build a network connection between Glue service and RDS. And Glue database is a container that store data catalog. The data catalog is a container that store all the metadata that generated by the Glue crawlers. How to create a Glue connection and a Glue database is not the major part for today's talk. So if you want to learn more details about Glue connection and Glue database, you can check our YouTube channel. This Lake Formation workflow role is for our blueprints could access Glue resources, Lake Formation features, and data in the data lake. You could refer the link here to check details IAM policies. Okay, let's start. Okay, let's start demo. Here's the Lake Formation console. We go to Blueprints and click Use Blueprints to create a new blueprint. So there are 5 types of blueprints. The first 2 are for database, and the rest, the 3 of them are all related to logs that we will skip those 3 types today. The database snapshot means the blueprint will do bulk load for all the data from your database and certain tables, import them to S3. And incremental database will only load the new data from where it stops last time. Then we could choose the Glue connection that we created before. And here we need to give the target database name and also the table name. Here we want to import all the tables from that database. We could use exclude pattern to exclude tables with this pattern. For today's demo, we just leave it blank. The target database is the glue database that we store the data catalog. Choose this one. And target location is the place you will store the imported data. Since we migrate the database data into S3 Data Lake, we need to specify a location to keep those data. Let's store the location that we registered just now. The data format, we just keep it as Parquet. We can also choose CSV. Then we need to determine how often we want to run the workflow. You can run it on demand or schedule, make it a schedule. Then we give a workflow name and use the IAM role that we mentioned previously. Give a table prefix. So the maximum capacity means how many DPUs we want to allocate to the glue jobs in the workflow. The more DPUs we give, the more computing power a job should have. And concurrency means how many concurrent jobs we want to have. We can all keep default setting for both of them. Then we click create. Okay, since it may take more than 10 minutes to create and run the workflow, I will show you the blueprint that run already. So here is the blueprints. We created it and run successfully. Let's view the graph, the workflow graph together. And you can see it will jump to the Glue console. Yeah, here is the workflow graph. Let's zoom in a little bit. Yeah, as you can see, there are lots of Glue features are generated automatically for us. Like this is a scheduled, this is on-demand trigger, this is Glue job, this is crawler, this is a conditional trigger. Let's go to the Glue database to see what output we have. So this is the Glue database, and we can view the tables it brought. As you can see here, that some of the data are in Parquet format that actually generated by our workflow. Now we can query it with Athena. Let's filter out all the Parquet files. Okay, let's query it, view the data, and it will bring us to the Athena. And we can see the tables here. So this demo basically show you how we integrated Glue services and Lake Formations, Blueprint, and also the Athena. It is pretty cool. Let's go back to our presentation. Okay, let's recall how blueprints make our life easier during this ETL procedure. By using blueprints, instead of creating Glue resources by ourselves, we only need to give mainly 3 inputs to the blueprints. Then it will automatically create a Glue workflow for us, which contains all other Glue resources that you can see from that chart, from that graph, from that workflow. We have triggers, we have jobs, we have crawlers, and the 3 inputs we gave to blueprints are first we need to provide the source information, include the target database and target tables of the database. And also we need to give the glue connection. Second, we need to provide S3 target location to store the output files. And we need to determine the file format, either in CSV or in Parquet. And lastly, we need to give the determine how often we want to import, how often we want to run the workflow. Okay, at the end of my section, I would like to summarize something that you can take out. The Blueprint, as a very convenient feature, it still has some limitations. It currently only supports several types of database that I listed here, and also another 2 data sources, CloudTrail and load balancer logs. So Blueprint will generate a glue workflow, includes glue jobs, but the default job doesn't have complex transformations, doesn't have complex logics inside. But you still can customize the job script after the workflow generated. And if you have incremental ingestion requirements for your database, which means maybe the data schema of your database table may change time to time, then it is required that there's assigning or designing key in the table that you want to ingest. So based on those limitations, we could summarize that what is the best case to use Blueprint. First, it's very convenient if you have a one-shot job to ingest the whole database or certain tables without doing many transformations. We have exactly similar cases in Ascending. We have worked on this kind of one-shot job, and we use the Blueprint to accelerate the data ingestion process without inputting too much developed efforts on it. The other use case is when the transformation may be needed, but those can be done after they loaded into the data lake. Then you can do further processing with other tools that you are familiar with, such as Lambda or EMR. Like if you remember the Toyota case I showed you at the beginning of my section, they ingested the raw data first, then stored, decoded, and enriched the data in the data lake after processing through other sources like Kinesis, Lambda, EMR, and so on. Okay, next, Sean will discuss the permission model in the Lake Formation. I will stop here. Sean, you're on.
Yeah. Thanks, Celeste, for introducing how to import the data into the data lake by using Blueprint. My name is Sean. I'm a software engineer at Ascending. Now I'm going to talk about the security model in the Lake Formation. So into this data-driven world, the data breaches can affect hundreds of millions of people at a time. According to a record, a professional networking giant saw data associated with 700 million of its users posted on a dark web forum in June 2021, impacting more than 90% of its user base. The cloud security at AWS is the highest priority. In the AWS, we can get the benefits from a data center and network architecture that is built to meet the requirements of the most security-sensitive organizations. The AWS Lake Formation makes it easier for you to secure and manage the data lake. First, the Lake Formation provides the secure and granular access to the data through a grant or revoke permission model that augments the AWS IAM policies. The data administrators set up the user permissions on Lake resources like database, tables, and columns. And second, the users like data scientists and analytics can use the full portfolio of the AWS analytics and the machine learning services, such as the Amazon Athena, to access the data. And third, the configured Lake Formation security policies help ensure that the users can access only the data they are authorized to access. So with a data lake, the goal is to have the fine-grained access control to data. in the lake formation, we can specify the permissions on databases, tables, and columns rather than on the buckets or objects. For instance, as we can see on the right side, we have a table and there are two users, the user 1 and user 2. So we can just share the partial columns to the user 1 and share another part of the table to user 2. So in this case, we satisfied all the use cases and at the same time, but keep the data secure. Next, we're going to talk about the lake formation security model. Let's say the data administrator sets up the user access in the lake formation, and the users want to access that data by using Athena service. So how can we make it secure? Well, each time on Athena principles, it can be the user or group runs a query on the data lake. The lake formation verifies that the principal has the appropriate lake formation permissions to the database, table, or S3 location. If the principal has the access, the lake formation vends the temporary credentials to Athena, and then the query runs. And here's a request flow, shows how the credential vending works in the Athena on a query by query basis for a select query on a table. So as we can see in the diagram, first, a principal runs a query in Athena. And second, the integrated service like Athena analyzes the query and checks the lake formation permissions to see if the principal has been granted access to the table and column. Next, if the principal has access, the Athena requests credentials from the lake formation. Otherwise, Athena will issue an access deny error. And if everything goes well, the lake formation issues credentials to Athena to use when reading data from S3 along with the list of allowed columns. And then Athena uses the lake formation temporary credentials to query the data from S3. After the query completes, the Athena will discard the credentials. So this is the complete workflow about how Athena accesses the data registered with the lake formation. So yeah, as we can see, the AWS Lake Formation is backward compatible, which means that the AWS, if you have an existing AWS Glue data catalog, you can choose either continue to use the original IAM permissions for Glue, or you can upgrade to the fine-grained lake formation permissions. So AWS Lake Formation offers keywords-based search across all the metadata, allowing the addition of attributes like the data owners, store word, and other as the table properties. Furthermore, the data sensitive levels, column definitions, and other column properties can be added as well. User can also view the data of the specific table with the help of Athena. And next, let me show a demo of how to search the tables by different ways. So here's the AWS Management Console. Let's go to the Glue console. Yeah, here's the AWS Glue table list. As we can see, we can use searching field to filter by attributes. We can search by, let's say, classification, databases, data edit. And here, we're going to search by database. So let's click database, and we can search by Glue demo database. Yeah, as we can see, all the tables under the Glue database are shown here. And also we can just search by the keyword. Let's search by demo keyword. So this time, since I didn't click any attributes, just have a keywords demo in the searching field, it returns all the tables that related to the demo. Okay, let's go back to the presentation. Yeah, the AWS Lake Formation console can be used to see recent activities and detailed alerts of who is accessing the data in the data lake and what they are utilizing the data for. You can also download these audit logs for the further analytics. The notifications for the data ingestion and cataloging are published to the Amazon CloudWatch events from where they may be accessed for auditing. And next, I'm going to show a demo about how to grant user access to the lake formation. So let's go to the lake formation console first. Yeah, as we can see, we have our lake formation database here. So now I'm going to grant one of the user to our lake formation tables. So let's go to the tables. And for the demos reason, I'm gonna grant a user to our test table. It's called demo meter test public teams. So we're going to use this one. And here we click action and we can see grant. So here we can select the principles we want to grant. It can be IAM user and roles or the SAML user and groups, or you can grant the permission to the external AWS account. So here I grant to the IAM user, which is myself. And also we leave the default value for the LF tags or catalog resources. So here we're going to select the specific access permission to grant. So for the demos reason, I only grant a select permission to all data access. Okay, so after grant access, after grant the permission, we can go to Athena to make a query to see if we can query the data from the data lake. So I'm gonna run a query to fetch the records from the table we just granted. Yeah, as we can see, we can have one record here. So we can get the data by using the permission control. And let's go back to the lake formation console, and we are going to revoke the permission. Let's go back to the table and search the table name. Still this one. And I'm gonna click view permissions. So as we can see, we have our principles here. We're going to revoke that. So after revoke the permission, this IAM user will no longer be able to access our table. So let's run the query again. So as we can see, we got an error saying we don't have the permission. And next, we have two small quizzes to help you check your knowledge about the lake formation security model. Yeah, okay, thank you for answering the question. As I can see, for the first question, a lot of people can answer correctly. Some of you may choose to the email address as a principal that can be granted permission in the Lake Formation, which is not true because currently they only support IAM user and role and external accounts, and also the SAML user. And for the second question, so I can see some people are selecting the role as the permission level. But for now, the AWS Lake Formation only support the database table and column as the permission level. I think in the future release for the Lake Formation, they will support the role level as the permission control level. So yeah, next we will invite Sean from AWS to introduce the recent innovations about the Lake Formation. I will stop the share.
Okay, great. Let me find my PowerPoint and now I'll share my screen. Actually, I think this is the wrong screen. All right, now I need to find the right slide. Okay, so thanks, Sean, the other Sean, for covering the security model with Lake Formation. There is definitely a lot of things you can do with limiting access and doing cross-account sharing, and be able to use the assets that you have within Lake Formation and have an audit trail, right, to set up your Lake Formation. So next I'll talk about the recent innovation. Most of those are covered through the 2020 reInvent. If you are interested in it, in the talk, you can definitely see that in the reInvent videos as well. So recently we have enabled multiple, give me one sec. So we have enabled multiple new regions, for example, in Milan and Beijing and Sao Paulo. And then we have added new features as well. For example, Amazon QuickSight, Blueprint Performance, integration with Amazon EMR, label enforcement, for example. We'll kind of dive into some of those in the next slides. So customer has asked us for three things. For example, streaming updates and deletes. For example, on use case such as database replication and privacy regulations, especially with the GDPR and ACMP in the States. Even finer grained security such as role level permission. So that is also what Sean was covering earlier, right? With columnar and table-based access, now we're putting in role level permission, so you can actually trim your permission down to a single cell, right? If you think about a table, now we have the columnar security, and now we're going to have a row level. So if you intercept the two, you can have a cell level secure sharing. And managing files and tables in an S3 that's currently not organized in an optimal way. So customer asked us, how do we make our analytics go faster, right? So what we did in reInvent 2020 was we released transactions, row level security, and acceleration. With these additional features, your Lake Formation data lake can be safely updated. It can be secured across all the people and application which want to share the data, and the individual access is accelerated to provide a better experience. We have now enabled new APIs, update and access APIs. They are open and public, which would allow you to build your application on top of it. Transactions, row level security, and acceleration. I'll kind of talk about this. Transaction, just like the name suggests, right, would enable you to run atomic, consistent, isolated, and durable transactions, just like in the RDBMS. Row level filtering for finer grained security, and finally optimization, which runs and manage the files and tables on S3 for faster analytics. So kind of dive into the acceleration and what it actually does in the backend. So why transactions? Why would anyone want to build transactions on our data lake? Some of the use cases we have seen our customer doing is they run complex ETL pipelines that are super complex and require transactional insert. Update and delete. So multiple users can interact with the data lake simultaneously. You don't want to have two developers to update at the same time and then have a corrupt file. So now we are able to have a ACID compliant data lake for multiple users to interact with the data lake simultaneously. Okay. Next, we will talk about we'll talk about the governed table. So with the ACID compliance, this is coming in along with the governed table. This is in preview. It's not currently available in the console. So even if you go into the console, you won't be able to see this right away. You would have to go through a preview link, which I think in my next slides, and you'll see it. Governed tables allow you to do ACID transactions, which manage your metadata and data, allow you to run multiple operations across tables, users, engines. For example, you're running query in both EMR and Glue across multiple tables. This might be separate teams, different tools, and all of them can be run at the same time. There's no lock-in, meaning that you're able to store your data in S3 without being locked in. You store your data in the format you want. And I talked about you can have any kind of open file formats that we support, and we support most of the open file formats: Parquet, XML, CSV, JSON, and you can import and export your metadata to any of the external formats like Apache Hudi, Delta Lake from Databricks, or Iceberg. We'll provide you with the blueprints to push and pull data into and out of the data lake. This is what I talked about earlier, right? We don't just want a data lake, but we also want the function around how to bring data in and out of the data lake at your convenience. And finally, you're provided with version control. You can go back in time and access the older version of data and run query as of, for example, January 2021. So this is enabled through the version control in S3, right? You can have version controls enabled in your S3 bucket, and you can always go back to previous versions. And time travel in data lake is enabled through version control in your S3 bucket that's underlying the data lake itself. Security being job zero at AWS. We want our customer to have all the tools they need to govern security at the most granular level. So just taking this as an example, right? You may have a huge fact table across groups and departments, but with the patient records, admins should only be able to see the records. Admins should see all the records, while doctors and nurses should only see their patient's record. They shouldn't be able to see another doctor or another nurse's patient's record. And then taking retail as an example, right? Store managers would see their store's records, but a regional manager should be able to see all the store's records. And today, you kind of require multiple redacted data sets, but with row level security, you are able to limit the data set based on individual row level. So I think Sean earlier mentioned about table and column level security policy. Now with the row level policy, what this actually looks like is AWS is using a PartQL, which is a SQL-like formatted language, which would enable you to use where clause in your statement to restrict row-level access. And Lake Formation, again, supports many S3-based table formats, both open and managed, right? So I talked about the governed tables, but open data sets or the open tables that are not managed through the governed table is also able to use the row-level security policy. And with the row-level policy, it's very easy to audit the permission and access, who did what and when. Acceleration, I'll kind of talk about, what it does, right? Acceleration enables faster access for analytics based on what we gathered from our customer. More than 80% of the return rows are filtered out. So, if you're writing a SQL statement, you're doing, for example, select star from patient, and where you're putting the where clause saying something, but 80% of the return rows are really filtered out, and there is a lot of wasting doing that query. Currently, all the files are being read and retrieved with acceleration, right? Smaller files are being merged. So if you think about, smaller files such as 1 kilobyte to 50 kilobyte files that are streamed into your S3 bucket, those files are being merged and often generate around 50 megabytes to 100 megabyte files, which would enable query performance to be much better. Also, bigger files are being compacted. So pushdown allows queries to retrieve only required data from Amazon S3, which can improve performance and reduce the amount of data transferred. So as you can see on this diagram, PartQL is where the filter is being used for, and storage optimizer compacts smaller files into larger files, merges deltas, which creates, like I said, around 50 to 100 megabytes of file. It's all done for you, it's managed, and you just need to enable the acceleration capability, and then we'll just automatically do it for you. Data sharing across accounts is hard, right? Originally, what customer did was they had one data lake in, for example, their accounting department or finance department. And when they share the data, either they have to copy or duplicate the data and put it into another account, or they look at open up the S3 bucket policy or giving IAM in a cross account role to be able to retrieve the S3 data and then build a data lake from a different account. But the problem with the first one, right? The first one is expensive, and sometimes you would make a mistake and there is no system of record. Well, with the second one, you open up a S3 bucket and then you give cross account IAM role permission. The problem with the second one is that you lack the more granular policy, right? With data lake, you can set columnar and table-based and even row-level security, but with S3 open permission and IAM cross account, you lose that capability to set granular policy, and the size of the limit is coarsely grained. So with AWS Lake Formation cross-account sharing, now you're able to share Lake Formation or your data lake in a central account to other AWS accounts. So as you can see on the left-hand side, this is our producer, which contains our data catalog, and the resources include the sales and opportunities table, which would grant AWS Lake Formation to share the data catalog to a consumer account. And the shared resources are, again, sales and opportunity. And this is in the background creating a resource link. And in this case, what you're doing is you're just granting permission to consumers. In the console itself, you just need to create on the table, click on the table, and then click grant, and you should be given an access to grant cross-account sharing. Again, in the consumer side, once you have the resource shared, you can integrate with the second account, Amazon Athena, Glue, EMR, and the Redshift. And you are able to interact with the data lake from the central account with essentially, if you have another department and the cost is associated to that department, the Athena, Glue, EMR, Redshift would be attributed to that department. And common data sharing topologies, most customers, what we see is you have a centralized hub and spoke model, which you have a central data engineering team and data architect that architects the entire data lake and then share it cross account to different departments, and departments would then use their analytical engines and make ad hoc or even on a daily basis, for example, loading data for some business, creating business value through analysis. Cross-account and cross-org and companies, for example, vendor, supplier relationship, right? You would, for example, a vendor would create a data exchange or some kind of data lake which is resellable. And they would sell that access to, for example, somebody who needs that data. Or even if you think about a franchise, right? Some of the franchise would need to, you would have a central organization which shares data to different smaller franchise who needs to get that data. So there are different sharing topologies. Again, with the data mesh, you could have multiple data lakes, and those could be from the same company, from different companies, and sharing that data lake would enable driving business values through both ad hoc analytics or continuous analytics. And there's no additional charge for using Lake Formation. Like we talked about all those benefits of how to use Lake Formation and how to create value through Lake Formation. There's no cost. You will only pay for the services used by Lake Formation. For example, your Lake Formation would use Glue data catalog and jobs and crawlers in AWS Glue for loading data into data lake. You get charged for using Glue as its public pricing, right? And similarly, your data is stored in Amazon S3, and you would just get charged for the storage as per S3's public pricing. So Lake Formation started in, I think, 2018, 2019. When it first got started, it was just a architecture that's on top of S3 and hosting all the data in a data lake. Integrates with QuickSight, Glue, Athena, EMR, Redshift, and eventually everything popped out. And now what we can do with Lake Formation since reInvent 2020 is we added new public APIs. We enabled asset compliance transactions, unified governance, which allow you to share data across account, as well as having column, table, and row-based policies. Acceleration would enable customers to have more compacted files instead of little small streaming files, which slow down their analytics. I actually did a demo or did a workshop myself. By having acceleration turned on, I was able to increase my analytic workload by at least 10x. Because now instead of the 3 kilobytes files, now I have 50 megabytes files, and it just makes it so easy to query across my S3 data lake. On top of everything I talked about, there is no lock-in, right? Your data is in S3. You can take your data wherever you want. You retain the control of your data. We support open standards formats, JSON, Parquet, Avro, and it's very efficient to share. You can share your you can use your metadata. You can send your metadata to, for example, Apache Hudi, or or Delta Lake, for example, if you want to take your data somewhere else, we make it very simple for you to do that. And then again, when I first started this, I you know, with the current architecture in place, we call it the modern data architecture, and Lake Formation is the foundation for analytics on data lakes. And currently there are many customers that are using Lake Formation, and I'll kind of talk about what they think about Lake Formation in the next slide. BI Manager from IATA sets up granular user access for audit access rights and permissions. So this is one thing that bigger organizations want to put in place because they need audit trails. They need to know who did what and when. Head of DI from OneFootball uses data lake to simplify and eliminate ETL workloads. You may have those workloads or may have those ETL pipelines that run for hours, right? And having a data lake, sometimes you don't really need a very complex ETL pipeline. Everything goes into an S3 bucket. CTO from Kerbal uses ML Transform to bring down data processing under 4 hours. And they have really liked it because now that the accuracy have improved nearly by 100%. GoDaddy, the CTO from GoDaddy, Charles Beatnall, uses hub and spoke model to govern access from multiple siloed data. So as I talked about with bigger corporations, audit trail is one of the most important things they care about, right? Data governance, permission sets. Earlier, everybody mentioned, you know, what are your challenges with your organization? A lot of people said analytics, right? But in order to make sure analytics work, you would have to set in some kind of governance in place to make sure the people that's querying your data is the people that you want them to query. Tech lead from D2C shares data from multiple AWS accounts to enable both access control and, of course, driving more business value, because now they are able to have, for example, finance to be able to access engineering, and having those sophisticated data management, they are able to get a proper data lake set up. So before I conclude, I hope I didn't really hear anybody have any questions. So if you do have any questions, please let me know. And all the experts from Ascending is here to help you. And that concludes my quick kind of talk about the new releases that are happening in re:Invent. Thank you.
Okay, thank you, Sean. Thank you, Sean from AWS. Thank you, Sean from Ascending. Thank you, Celeste and Ariel. Before we close our immersion day, I also want to again thank you all for invest time in our event. We hope you leave this event with some thoughts and insights. As Sean mentioned, if you have any questions, feel free to reach out to us after this event. We are happy to help. Okay, I think that's it. And also, sorry, forgot to mention one thing. Keep an eye on your email. We will send out a gift card to people who stay along for the entire event. Thank you.